Okay, good afternoon. It's 1 o'clock. Especially in the front row, we'd like to start the meeting. If the class could be quiet, it would be appreciated. Okay, great. Thanks. Welcome to DINRG, Decentralization of the Internet Research Group of the IETF. My co-chair is Lisha Zhang, and my name is Dirk Kutscher. Great to see you all again. Okay, quick usual housekeeping notes. So we operate under the IETF follows the IETF IPR guidelines. So in essence, this means if you contribute something or you hear something that is related to IPR, you are expected to notify us in a short time. Okay, thank you. There's also the privacy and code of conduct that we operate under. So if this is new to you, please read these documents carefully. And then our usual reminder. So this is the Internet Research Task Force. We are not setting standards for the internet. We are doing research. And so this gets sometimes mixed up because we are using the, say, RSC publication stream. So typically when these groups do RSC publications, they are either informational or experimental RSCs. They are typically intended to support research, to help people evaluating some concepts and so on, but they are not internet standards. All right, so we have a mailing list. Please consider subscribing. Most importantly, to start the meeting, we would need a note taker. That's really important. The job of a note taker is not to write down everything that is presented, but capture the essence of the discussion. And as usual, we cannot move on until we have found one. Please consider helping and saving us some time. Note taker, please. Thank you, guys. Most appreciated. Okay, great. So let's start the meeting. Quick reminder. So I just mentioned so the RSC publications and so on. So internet drafts and RSCs are not the only ways how we can disseminate our results or share some ideas. So we have a wiki for DINRG, and so we try to use that more for, things that are noteworthy that maybe are not optimal for like internet draft formats. And we'd like to grow this. So maybe check it out and see how you can, if you can have additional information you want to share, or you find interesting papers. So we kind of started populating this, but this clearly needs more input. And admittedly, it hasn't grown a lot in the last months, but so let's try to become better at this. Yeah, so for example, when you look at it, you will find some papers that were related to previous presentations, also the report of our previous workshop, for example. And we would just like to continue adding relevant and interesting material there. Okay, so today we have, I think, a pretty exciting agenda. So we have 2 hours today, and so we start the presentation by Li Xing about the cyberspace regulation in China. And after that, we have a remote presentation by Wilfried Pinfold on delivering social and municipal services. And then we have Sindhu Ma, Varun Patil, and Tianyuan Yu on a prototype presentation of a local first application. And we also would like to discuss a little bit some ideas and potential future work coming from RC 9518 by Mark Nottingham, which we think has some really nuanced, balanced thoughts about centralization and decentralization. And let's see how we can discuss this later. All right, thank you very much, Li Ting. I give you the clicker. Let me just switch the slides.
Okay, good afternoon.
Do you want to use the clicker? Or?
Okay. Actually, I'm not really the right person to give this presentation because I'm technical. However, Professor Chang asked me to give one, so everything is based on the open resources. Okay, first introduction. Actually, this year is the 30 years anniversary of Internet get into mainland China. That's very important. And currently, China is the largest internet population in the world. Still, probably India will exceed China in the near future, but currently it's still. The internet greatly boosts the economic development and the technical innovation in China. And since internet decentralization is a cross-discipline challenge involving policies, economy, and technology. This presentation is trying to list the Chinese cyberspace regulations in the past 30 years for the future study. So first thing, the sources. Actually, when Professor Zhang talked to me, I basically get information from these two URLs. One is Cyberspace Administration of China, that's a Chinese entity, government entity. Another is Ministry of Information Industry Technology, another one. The first one is more related to the policy and the propaganda things. The second is more technical. The second one is the formal MPT, Ministry of Post and Telecommunications. So this is Chinese. I just try to give you idea, and I use the ChatGPT to translate. So that's basically like several categories: the laws, the administrative regulations, and the departmental charters and the normative documents. So that's basically the thing. And starting from 1994, whatever things. And if you go to the URL, you can find out. So I just gave you my observations for this. Okay, the initial observation. Actually, the first, this is the distribution of the laws, the administrative regulations, and the departmental charters, or those kind of things. You can see the laws, that's the blue one, it's the small part. And the orange, that's the regulations, and the gray one are departmental something, those kind of things. That's the space distribution. And on the right, that's the first laws and regulations and charters. That's the distribution 30 years from 1994 to the last year, right? Not this year, I didn't update that. So maybe something new. Okay, you can see the distribution where basically it's some kind of uniform distribution, right? Even some bursty, so that's the way. This just gave you the fact. And then, because IETF is technical, so actually I try to separate the subjects, or categorize the subjects. The first is the subject. Okay, the infrastructure and the applications are layer 3 and the layer 7. So this kind of separation. The blue one is the infrastructure and the infrastructure security. And the orange one, applications, content, and the users, those kind of things. It's about half to half. And then in the infrastructure and the security, actually, they are about half of the regulation talk the infrastructure itself and the half related to security. Also half. So this kind of distribution. So actually, you can get some kind of conclusion. Chinese government for regulations, whatever thing, they really pay attention on security. So that's basically the thing. And then actually the trend. That's interesting. Okay, from the quite beginning, actually, they are decentralized. From the first part of the history of the internet in China, okay, because they are the propaganda department, the MII, the cultural department, the state department, and those kind of publication departments. They all issue regulations for the internet. And then later then, there is called Office of Central Leading Group of Cyberspace Affairs. That's basically the propaganda governmental, and everything should follow that. So that's actually in China, the regulations from decentralized structure to centralized structure. That's the current situation. Another thing is more interesting is technology, business, and the regulations. I can give you two examples. For example, the blog. The first business, official business offered is 2006, that's the blog. And in 2018, there is the first regulation related to blog. So the business first and the regulation later followed, and the time is quite long. However, for AI, the ChatGPT, the regulation first, then China permit like Baidu to offer the chat services. So the second observation is from business first to regulation first. So from decentralized to centralized, from business first to regulation first. I'm just the observer. I'm not inside the government, but based on the history and the analysis of those kind of things, that's my own observation just for your reference. Okay, then actually that's the discussion. And okay, from my own thing. Actually, in the year 2016, the IGF, Internet Governance, and the WinSurf with two people published a white paper, discussed the internet fragmentation. I thought what I discussed is something related, that's my feeling. So in WinSurf's white paper, actually he talked about technical fragmentation, governmental fragmentation, and the commercial fragmentations. So and quite interesting, like a technical, like DS related or address or even protocol related. And I'm happy because I involved into Behave working group and like a software working group for translation between V4 and V6. In WinSurf's white paper, actually, the communication between or split between different protocols which cannot directly communicate V4 and V6. And I believe I did something good for avoid V4, V6 fragmentation for the internet. Also, WinSurf talk about the domain names, whatever the split of the root or those kind of things. And the governmental thing, usually it's related to my presentation. They are the national things and the content censorship and e-commerce or regulations or localization of the data, all those kind of things. Different country has different rules. And as an engineer or academic people in IETF, actually we do not have much voices on that. And also commercial fragmentation, like the big giants, they try to get centralized out the internet and like creates. And the last one, actually, that's the one I added because I thought ChatGPT and the AI, that creates AI fragmentation. That's not created to WinServer, but my own add-ons like the computational ability, algorithms, data bias, or regulations for that. So actually, that's the current situation as an engineer or academic people, we have to deal with those kind of things. And actually, my idea is quite, I don't know, just my own idea. So probably this is time we have to somehow back to the original internet or original definition of the internet. That means the network of networks. If we can get together, then we should communicate globally. If some kind of thing due to technical, political, commercial thing, then at least in the network, it should work. Currently, like the root server or whatever, the domain name, DSAC or RPK, some kind of trust anchor is some kind of centralized trust anchors. So if it's fragmented, probably it won't work if we are using like a DS or even DSAC or RPK validation, those kind of things. Maybe it's not work. So probably we should have some kind of solution back to the original internet. So network can work and then connected as the global internet, it should work if it's connected. So that's, and then what's the key point from my think is actually the uniqueness of the addresses or names or whatever identifiers should be unique. Besides that, decentralization is a very good thing. So thank you very much.
Thanks so much, Ting.
Any questions?
Yes, we have time for questions. So if there's no question, I have one. So, you know, in some jurisdictions, you know, governments are discussing the problem of economic concentration, especially for like application service provider companies who own lots of data and have all kinds of business models on that. Are you aware of any discussion in China? So like economic concentration of like big web cloud companies? Is there any talks about regulating or putting laws into place?
I believe the government set more and more regulations. So actually that's some kind of kick out the international players. And the Great Firewall, right? But actually, one thing I like to emphasize, okay, many years ago, when the government people try to discuss if China should connect to global internet, actually some people in the government are very scared. And actually myself with some other people, we get involved, we post and talk to the people in the government at that time. Okay, the principle of internet is stolen forward, so we can set up firewalls and the people later make it as the Great Firewall. So without that proposal, probably China won't get to the global internet and we will not be here. Yeah, so that's, we should say, the good thing for Great Firewall, at least from the first stage of the internet in China. And then now it's too big.
All right.
Yeah.
Okay, we have Andrew in the queue.
Hi, thank you. Really interesting talk. Sorry, Andrew Campling. Since you mentioned the Great Firewall, it just prompted me with a question, which is, I hear it said quite frequently that one of the aspects of technical fragmentation specific to China is that the firewall blocks TLS 1.3. I don't know if that's true, and I just wondered, since you've talked about this topic, whether you may have any knowledge of that specifically. Thank you.
The details, I have no knowledge. Maybe like, I don't know. Jeff, you have something you can mention you're of the APNIC lab, you have something.
Next in the queue anyway.
I am next in the queue, but on TLS 1.3, we do a lot of measurement, and we certainly do TLS-based web retrieval, so 1-by-1 pixels. And ads are all over the planet, including inside China. So we get a reasonable collection of stuff from China. We have no control. Where's Andrew? Oh, okay, they're hiding there. We have no control over which version gets selected. It's a negotiation. So as far as I can see, from memory and looking at it, there was very little TLS 1.3 being used. But that's not whether it gets permitted or not. It's not my job to try and finger and prod the firewall. I'm sorry, it's just not my job. So, however it behaves is however it behaves, and that's just the way it is, as far as I'm concerned. But I did have an observation which makes me next in the queue. Where we are was a direct result, as far as I can see, of frustration in the United States and America in the 1970s, because when they digitized their network, the cost of the telephone service plummeted and the profits dramatically increased, and AT&T was on the nose. And the result was actually a deregulation of that private company's monopoly in the US. And the theory, the economic theory at the time, was that competition in amongst providers would get rid of that rich profitability and create value for consumers. And the resultant regulatory regime was not intended to curb behaviors of how telephone operators operated. It was intended to protect consumers from market dominance and market distortion. And in some ways it was peculiarly American, but oddly enough, there was a lot of pressure placed on every other developed economy to similarly deregulate their telephone system. And what happened was they didn't create more telephone companies because a telephone company is a massive investment. And unless you have a few 100 million people, you can only ever support one. Competition came in the form of alternate systems, including the internet. Now, the internet grew out of a complete absence of regulation, and it was basically driven by private capital investment inside a regulatory regime that did not tell you how to invest your money, but it told you when you'd started to manipulate the market beyond normal tolerance of market manipulation. Everything I've said so far, I believe, is not Chinese and not the Chinese social and sort of internal economic organization. My dim understanding as a foreigner, and I am, and I freely admit it, was that there was more of a central element of state enterprises in a compact or agreement with the central government. And services were provided much more like telephony, state monopoly in telephones. Folk who do internet is almost in sort of that environment. So the regulations in other countries is all about behaviors in the market. You seem to be suggesting the regulation in China is of a different form, about the behavior of those providers and the way they, not between each other and the consumer, but what they actually provide. Am I talking nonsense, or is this your observation too?
It's quite interesting. I did not really think in this way, so I need to think.
Right.
Yeah.
It sort of struck me in some ways that building a public infrastructure in private money with a sort of a regulatory structure that doesn't tell you what to do, but tells you when you've gone too far and you're abusing customers, is not really a system that has been adopted in other industries in China, as far as I can tell. And so the accommodation is that China Unicom, China Telecom, China Mobile, big combines, but largely with a state license to operate rather than strong competitive factors between the two, between the players.
The top level, both China Telecom, China Unicom, China Mobile, they are doing same thing, and they gave the KPIs to the lower, and in the lower level, very high computations. So that's the way it runs.
Right. So in some ways, change and evolution becomes change and evolution in regulation, as you seem to be hinting, whereas in other markets, change and evolution actually occurs through different forms of economic pressure in the marketplace itself, rather than in the regulatory structure that oversees it. Okay, it's just, that's as much as I can figure. It's just an interesting observation of the cultural differences going on here. Thank you.
Thank you.
Yeah, great. We have more questions. Robert.
Yes, I'm sorry. I'm far too short for the stand. Ugh. There we go. Can I be heard?
Yeah.
Marvelous. Just a
Maybe
quick follow-up.
state your name again for the note taker.
Sorry. My name is Robert Carolina. For our purposes of what I'm about to say, I'm a senior visiting fellow with the Information Security Group at Royal Holloway, University of London. And even with that affiliation, my comments are wholly personal and not to be attributed to anybody, friends, enemies, or pets or family. To follow up some of the comment just made by Jeff Houston, I would point out that the interesting situation that I think has a bearing on this is that in the US, the AT&T monopoly on both long and short haul communications was broken up using anti-competition law and was the process of taking a de facto private sector monopolist and turning them into competitive regional competitors and others. One of the thin end of the wedge of that process, though, came in the late 1960s when people fought for the right to connect customer premises equipment to the network without prior approval from the network operator. You know, long ago, before the 1970s, the world that we lived in was such that the only person you could buy a telephone from was the telephone company. It was a crime to plug anything into the network that wasn't bought from them. And that freedom to choose customer premises equipment, I think, helped significantly in the development of what became the internet. The European situation was slightly different because in there we had state-owned post and telecom operators that were privatized, and privatization counterintuitively creates increased regulation to enable new market entrants and to enable competition. What does this have to do with fragmentation? I want to come back and agree with what I think you may have said, so forgive me if I mischaracterize this, but I'm interpreting it as the type of fragmentation that most significantly must be avoided at all costs is what you've described as technical fragmentation. And I would collapse that even further down to the loss of a single name and addressing space. If we lose a single name and addressing space, to me, that's game over, because the innovation that we've seen has been predicated upon the ability of manufacturers and coders around the world to develop, build, and sell equipment to a common standard, which this organization is obviously at the center of, the IETF is at the center of. The other points that you make, I personally don't have a great deal of confidence in avoiding the types of fragmentation that are in every other one of your categories, in part because, you know, sovereign states got a sovereign state. We see the majority of sovereign states all regulating on content, including those who for decades have said, thou shalt not regulate on content. They're still doing it.
Yeah.
So it's a game that everyone's playing.
Yeah.
The fight, the focus, the thing to hold on to at all costs is a single name and number space.
Mhm.
Without that, we have nothing.
Yeah, I fully agree.
Okay, thank you, Rüdiger.
Rüdiger Volk. Kind of, Geoff, what you were telling about centralization. Well, okay, I think you were talking essentially about layer 3. Kind of, and well, okay, you were listing the very limited number of national ISPs, and my understanding is centralization also happens at other levels, and kind of understanding of how that space is organized in China is even harder to understand from the outside, except the press once in a while tells, yes, the government slaps the hand of some billionaire. Most of the columns are kind of, at least including stuff that is high above the and for the chairs, well, okay, what is kind of the focus of the research group? Is it just layer 3? From the economic weight, the top level certainly is much more valuable than the layer 3 infrastructure, and much more dangerous.
Right. So, I mean, we are discussing all of these things here, right? So, technical, economic measurements.
And I would just, in response to your question, please see our report for the 2021 DINRG workshop, where we actually stated there's 3 factors intermingle together. There's the regulation, there's the economy, and the technology. I think we need to understand the balance among all the 3. So China may be a special case, but in general terms, I think that's how the society operates.
Okay, so we have closed the queue, so Tobias gets the word last.
Okay, so I would like to make the point that technical fragmentation is usually kind of dependent on all the other forms of fragmentation. Because if we look, for example, at the blocking of Sputnik News in Europe, we could see that the voluntary participation in bottom-up internet sanctions of European tier 2 and tier 1 providers led to also a loss of connectivity to these sites in Africa. And that essentially entails the loss of the single addressing scheme, because all of a sudden those addresses, even though they might not be considered blockable in Africa, no longer work for that single addressing. So if we have governmental fragmentation, commercial fragmentation, those might actually cause technical fragmentation in the end.
Okay, thank you everybody, and thank you very much, Singh. It was very interesting. We understand it's not easy to find out this information, so but definitely appreciate your report. So maybe we can come back to this again in the future and learn more about the cyberspace regulation. Okay, I'm switching slides. In the meantime, please don't forget to scan the QR code if you're in the room. Just give me 1 second. And so next, it's our pleasure to welcome Wilfried Pinfold remotely. So Wilfried is the president of Open Commons, a company that provides collaborative services, open software and standards, and that works closely with NIST in the US. And Wilfried will explain more about this. I'm giving the slide control to you. Just give me 1 second to find you on the list here. Here.
Can you hear me? Are you able to hear me?
Yes, we can hear you.
Perfect, thank you.
Welcome, and thanks for attending the meeting.
No,
You
no,
have the
thank
floor.
you. This is excellent. Great, thank you. I really appreciate it. So I'm going to talk a bit about a challenge that we have experienced. My background is Open Commons, which works very closely with the National Institute of Standards, focuses on a program that National Institute of Standards calls Global Community Technology Challenge, which is really a smart city program. It's looking at ways that technology can be used to provide social and municipal services, both software services and IoT services. So how that technology can be integrated into the infrastructure and the fabric of a community. And we ran into a problem that I'm going to describe here, and why the decentralized internet looks like a very good solution to that problem, and how we've been approaching trying to build applications that use the decentralized internet. And I'll talk a little bit about that. This slide tries to look at a very small piece of the problem, but I think it illustrates it well. The challenge is, and I'll talk about this in terms of the United States. I'm actually based in Portland, Oregon, and have been working closely with the United States through NIST, and also with Europe through the EU, who have similar problems. And I believe that these are relatively common challenges. So you've got two ways to look at how we deliver services. So this is broken down by state. Each dot here is each sort of grouping of 5 dots is a state. And what it's trying to show here is taking the federally mandated social services for all states, which states make those services available online, and whether or not they coordinate the application that accesses those services between those services. In other words, if there's just a single dot, like Alabama, the top left here shows 2 dots, Medicare and TANF. These are 2 services. It doesn't really matter what they are, but 2 services that are available online out of the 5 that are typically available. You can apply for 2 of them online, and those 2 use separate applications, and there's no interaction. So if you enter information into one of those applications that's needed in the other one, you'll just have to re-enter that information. Whereas if you look at Colorado, you can get at all 5 of these social services online, and 4 of them are coordinated. In other words, there is commonality between the apps. Once you're in and you've started to enter information like your ID and your social security number and other information, that's now in the application, and it can coordinate. Now, there are a couple of ways that you can start to simplify this model. One would be to sort of centralize a lot of this information, to start to coordinate. As you can imagine, Colorado has sort of centralized this information and carries it between these applications. The other way would be to say, let's create a decentralized infrastructure in which an applicant can enter a large amount of information that is private to them. And when they make an application for one of these services, there is an API that is able to extract that information from that individual's data store. And that information does not need to be kept by the state, because they know that on request they can get that information. And that actually aligns very well with the GDPR regulations and others, that you don't use information that you've gathered online for services or for functions that are not stated when you gather that information. And this is very much in line with how we do things in the physical world. typically you go in to apply for a social service, you'd provide your documents, they'd be given back to you. It would be checked off that you had shown those documents and that you'd identified yourself and the information was there. So this is a way of sort of shifting away from an idea of centralization of data, and that has huge benefits in a number of ways, not least of which is that the services don't actually need to be coordinated. And I use these 5 services as an example. I'll give some other examples of much smaller and simpler services that you'd want to be able to get, municipal services as well as social services that you'd want to be able to get that are very unlikely ever to be coordinated. And it's a good thing that they don't need to be coordinated, partly for privacy reasons, but also from the perspective of how they're managed. You can imagine that somebody who has collected a large amount of information, they lived in Nebraska, and they moved to another state like Delaware, it would be very frustrating to have to re-enter a lot of that information into the Delaware system in order to get those services. Whereas if that information was in a data pod or a data wallet that you carry, you would just move state and carry that information with you, log in, and the information would be found in your data pod or data wallet and shared. So that's the challenge that we're trying to address. I mentioned that there would be some other, I'd give some other examples. A very simple one that we use a lot in the United States, and I think in many countries now, there is a sort of fragmentation of public transportation options in addition to normal bus services and light rail services and tram services. There are parking services. There are often commercial providers of things like scooters and bicycles. There's quite often a car share service. We have all of those things in Portland. These are, in fact, the Portland services that are available. Also, in many cases, to take a trip, you might cross a municipality. You might start out in Portland and end up in Hillsborough. Therefore, you may be finding that there are, twice as many services as you could use. This is very frustrating because, if you have a scooter that you've logged into and you're able to use, and you can scan with your phone or use your phone app to get at, and you turn up on the bike that's there is a spin bike, then you have to reapply for that. And that's also frustrating. This idea of a decentralized internet where you have all of your own documents and all of your own information in a pod of your own, whether that pod is online or on your phone, you should be able to go to that scooter, and a simple API ought to be able to gather that information from your data pod and log you in and do all the certifications and proof of bank availability and any licensing you need in order to use that vehicle could be in there. So that allows you then to look for simple services like transit services, and be able to quickly use a data pod with your own information in it to get access to those services. And there are many more ones I've been involved in Portland. The community trust is a mechanism by which you can make small investments in your community. The One App is a way of avoiding having to replicate application information for housing. Small donor elections is a mechanism by which you can structure elections around small donations that are multiplied by a factor by state investments. So an election can be run around only small donations. Green incentives around encouraging people not to use their own private car, but move towards more public transit mechanisms, EV charging. All of these mechanisms could allow a fragmentation of services, but make it easy for an individual to be able to access these services without a burdensome sign up and login process. And we've been touching all of these. And so there's a real interest in structuring around the allowance of having pods or personal online data services that allow you to complete these transactions. So we've been working on a solution we call a personal access system for services that builds a decentralized infrastructure that allows individuals and companies and services to interact, where all the information is available through the two pods that are being brought together, the personal online data stores that are being brought together, and no other interaction is required. Sometimes you may want a third party to validate, but that can be done without that third party necessarily being informed that the transaction is happening. So all of the transaction can be done between two individuals. All the validation can be done through signed documents, and everything from very small transactions, stepping on a light rail train, or entering a building that has a fee associated with it. Small transactions like that, all the way up to large transactions, potentially things like purchasing a home, could be done with validated documents in a pod that then is a transaction infrastructure. And so you end up sort of pushing all of the data to the edge, and then having a series of applications and APIs that can find the data that's necessary quite quickly and complete a transaction. So personal access system for services has been started. It's in a very minor form at the moment. We are using it for a very particular purpose. You can find all of the code is on GitHub. We're using primarily the solid protocol that's a W3C standard, been championed by Tim Berners-Lee as sort of the framing for this. We have to bring in a lot of other infrastructure at the moment in order to make things work, and we're still developing components of the application that are needed around that. The solid protocol is still fairly new, and it only does the pods and the identity of the individual at the moment. A lot of the transactions we need to do are still being worked out. But it's a really interesting pathway to be taking in the development of a lot of this infrastructure. So that's sort of where we are. I'll talk a little bit. So these are links to the PASS technology online if you're interested in looking at it. We're very interested in anybody who can contribute and support this work. And I mean contribute as in provide knowledge and coding support to develop these programs. And there's plenty of knowledge that could be brought to expand the tool suite that we're using to develop this decentralized infrastructure. We are also looking at a couple of other decentralized systems that are out there. There's a system called the Beacon Protocol, which was developed in India, initially around transportation, but has now been extended into job applications and other infrastructure. And there's a group out of the UK, Hub of All Things, which uses a decentralized infrastructure that touches a lot of devices and other pieces, which we've been looking at. But PASS primarily today is built around the solid protocol. I mentioned at the beginning that we work pretty closely with the National Institute of Standards and Technology. They've developed. They don't develop software. They work with standards bodies to sort of guide standards development within the United States. They have developed something called the IES City Framework, which we work with to try and bring together common elements of the smart city infrastructure. We're working with them to build in a decentralized infrastructure around this because we think it provides real value in municipal and social services. So that's sort of the framing of this. I'm very interested in any questions you have and any thoughts you have that might support this work.
Okay, great. Thank you very much for your feedback. It was really interesting.
By the way, I'm sorry I haven't turned on my camera. I was unable to get the app to accept the camera on my system. So, so sorry you've had to look at an image of me
okay.
for this one.
Next time, maybe. So there's been a fair amount of discussion, and people shared some pointers in the chat. Just let me check. Are there any questions? So one question for me. So for the PASS system, can you talk a little bit more about the trust and security infrastructure? So what is the assumption? Is there like one PKI system for that? Or how can we imagine that?
So we're there are a number of standards that we are touching on, but we're still sort of constructing this. So there's a lot of discussion about whether we should use pod-to-pod encryption here. Depending on how you're using this system, one way to provide a number of different security infrastructure. So there are a number of ways to talk about security. One is, can you be sure that the person who's who you're sharing information with is the person you're sharing information with? Another is, do I need to protect the information that's being transmitted? One way to do this would be to provide public-private key infrastructure that would assure you that the individuals are who they say they are. In other words, that there's a unique private key, and you can exchange transactions to ensure that that person is who they say they are. And then you could use that to transact, you know, other keys that are used to do end-to-end encryption. So you could literally do pod to pod. You could encrypt within the pod in a private space, transmit an encrypted infrastructure that could then be, you could the other person could validate that you are who you say you are, and pick up and that you do a valid transaction with the public-private key infrastructure, and then get an encryption key for the document that you just received. That is not necessarily necessary in all transactions, and we don't intend to use it in all transactions. But clearly, as you start to do transactions that have real privacy needs and real financial impacts, that kind of infrastructure is going to be necessary. So we have the capability of doing that. Yes, I think that's probably the simplest way to describe it, but we are interested in talking with people who might have simpler mechanisms here. It would mean managing a large number of keys, because you don't want to use the public-private key for the document, so you're keeping management of keys that you've encrypted for individuals. There are a number of really interesting ways to use those keys. So there's a very good infrastructure there for how to do that.
Okay, yeah, thanks very much. So there are many links to additional information resources being shared in the chat, Wilfried. If you have a chance, that might be interesting for you. Thanks everybody for chipping in some ideas here.
Very interesting. Is there a way to save the chat for an individual? Do you know?
It will be in the minutes later.
That's perfect. Thank you.
Yeah. Okay.
Yeah. It's hard to keep track of the chat while you're presenting, and I saw there was a lot coming through and looked very interesting. So thank you for that. And yes, we do work with INRUPT. We've actually been working. There are two groups that work with the Solid protocol. INRUPT, which is Tim Berners-Lee's company, and is driving a commercialized version of this. And then there's also a Solid working group that is open. And we've been trying to keep as much of this as we can within the open infrastructure, even though there are some better implementations of pods and infrastructure software from INRUPT. And obviously, people can choose which way to go. We just didn't want to remove the option to keep this software entirely open for municipal and social services. But I would expect many implementers of this would upgrade to the full INRUPT platform.
Yeah, so this is Wes, really briefly. Everybody should know that the meeting is recorded and will be published on YouTube, and the chat log is published in Zulip. So it's definitely archived, and you will be able to read it later.
Yep.
Thank you.
Wes.
The chat log's also on the data tracker page for the group.
Perfect.
Okay, great. Thank you very much again, Wilfried. And we are moving on. Okay, so next we have the presentation by Tianguan Yu, Jin Ma, and Varun Patil on Workspace, local first corrective editing over NDN. And do you want me to advance your slides?
Yeah, that'd be great if you can do that.
Okay, just let me know.
So yeah, Harold, we are a team from UCLA. We have built this local first app over a technique called NDN and the local first app. And here, if you may, next slide, please. And the local first concept is first, I would say, presented by Martin Kaplan by the last DINRG meeting. Says we want to have softwares that we can access our data when we are in an offline mode, and we want to have users directly communicate with each other without having to, say, connect to the cloud. So if we can achieve that, then the user data can be directly, say, end-to-end secured and exchanged. There's no cloud in the middle, and you can edit your things locally, safely. And we have some other tools like the conflict-free data types that can merge the concurrent changes from other users seamlessly. So you would have a consistent shared, say, cyberspace. So you can build an application upon that. And the Workspace is one local first collaboration application with this local first concept in. And this talk would basically share our application design, our development experience, and what lessons we have learned. Since we are a team, so we would split the presentation into basically 3 parts, and each one would take one portion of it. Next slide, please. So think about me, Tianyu, and my colleague Xinyu, we are, say, writing a paper together. And ideally speaking, or normally speaking, we can use Overleaf, right? A website that can write papers on it. But the thing is that you have to connect to the application server. But think about another scenario. Next slide, please. We are on the same plane, and that is the real case. We are on the plane. We don't have internet access, but we do have, say, what I would say, local connectivity because he opened his Wi-Fi hotspot, so I can connect to his Wi-Fi hotspot. So we do have some local connectivity, and we know that we trust each other because we are in the physical vicinity. I can see his face. So how can we collaboratively write the paper together? Next page. Thanks. For example, if we want to have if we can have an application that we can access our, say, LaTeX data offline, and we make some changes on the LaTeX data and directly send that data to the other party. That would be a perfect application for this local first trend, and that's what we were doing. Next slide, please. For example, but the first question we came upon, that is, in the open environment, say in a Wi-Fi hotspot, how can a device, say holding my laptop, how can my laptop trust the received data coming from the network? And our solution is to enable direct, say, user-to-user data security. Next slide, please. And talking about user security, I think the first question we need to address is that how users obtain their identities. And there are several requirements for user identities. First, it has to be unique because the name identifier is used to identify individual users, right? And it has to be verifiable so that whenever I receive data labeled by, say, this, the user identifier is blah, 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 who produces this data, I want to verify that identifier claimer does own the identifier. and that identifier has to come from the internet, say, legitimate identification space, and that identifier has to be meaningful, because if we expect the other party came in, that party that the identifier that party use has to be some semantic meaningful name telling that, oh, this is your colleague. And what we are doing is we are leveraging identifiers from today's internet. So, for example, if you have email addresses, you just use email addresses of as the identifier, because that is unique, verifiable, because you can challenge with email, say, verification code. And this is definitely semantically meaningful. You can see that my colleague is from UCLA, CS department. And we can also use some other identifiers if email is not the most suitable case. For example, if I can use my, say, GitHub account as an identifier, but this is already unique because my username on GitHub has to be unique within the GitHub domain, and it is verifiable because GitHub has its own verification workflow, and of course this is semantically meaningful. So with the user identification design in mind, next slide please, we can say, oh, okay, now we have the identifier, we can start a communication. The thing is that the identifiers themselves, they cannot stand alone. We have to bind the identifiers with some keys. For example, if we have workspace owner between Xing and I, we create a workspace, one person to be the workspace owner, and that person can authenticate other users of this workspace by their, say, identifiers. If you provide your email address claiming you are the email address owner, I verify your email address and issue a certificate signed by the owner. So we can see from the figure below, we can create the trust relations within the workspace. Each participant has the key, and each key can be used to sign the change published to the workspace. Next slide. I think Xingyu will take over this part.
Yeah, so let me introduce how this workspace actually work on the shared document. So next slide. Yeah, so the document is shared. It contains, we just use this latex document as an example. It's mutable and it can be edited by multiple authors. And it is what is shown in the front end. But on the back end, we want to change this document into multiple changes. Here, each change is an immutable data packet, and it has a single producer, which means it's written by a single author, and it's persistent in the storage, and the actual change is propagated in the network. The reason why we do this is first because the document is always in some kind of dynamic state, so we want something immutable that can be easily handled by the network. And also, we can securely tracking who did which part of the change by let the author sign this change. And also, this gives us the ability of sync up the document, because when two people get exactly the same set of changes, then it means they can reassemble the same version of the document. So next slide. We achieve the consistency by CRDT, which is an algorithm that produces the eventual consistency based on the changes. So the CRDT algorithm can sequentialize the changes to solve conflicts and reassemble the document. It can also make our change to the document into the individual changes. And there's mature algorithms and implementations for CRDT. So in our application, we use it as a black box. Next slide. So now suppose when I made a change on the cursor part, I add a text called add some text. So the CRDT library will capture this change and convert it into a change. Let's say insert, add some text, and add the position 118, and put some internal data. Next slide. And then, because I have already joined the workspace, so I have my identity and I have a certificate. So I will sign this new change and make it a data packet that contains my changes and my author. I will save this packet into the browser storage and also publish this packet through some sync mechanisms. The sync mechanism will be introduced later. So next slide. And now suppose Tianyuan is my colleague. He's listening to this sync. So after he subscribes to this sync, the sync will get him this new data change. And Tianyuan will also save this data change to his browser's storage. And also, of course, he needs to verify that this is produced by me by verifying my signature. And after that, he gives this change to CRDT. And CRDT will compute the change document based on his current document version and this new change. So eventually, he will reach the same document as what is shown on my screen. Okay, next slide. So now let's talk about how do users exchange data. So this will be handed over to Verong.
Okay, so Shini already talked about how we generate and assign the data, but one key aspect of building a decentralized application is that we cannot do what's on the left. We cannot have one centralized server or even a cluster of centrally controlled servers that actually help our users exchange their data. And so we need to do this rendezvous, which is two users meeting each other, exchanging the data. It has to happen inside the network for our application to be truly decentralized. And for that, we use an NDN network, which is exactly what it is designed for, to let the users directly exchange their data without a central server. Next slide, please. And so to actually have a concrete running implementation of an NDN network, we use the NDN testbed, which is a global network running NDN software. It's spread across 4 continents. There are 22 nodes that are contributed by universities, institutes. It's basically an actual NDN network that anyone can use. And you can also join. If you have a node, then anyone can join. It's something like the early stages of the internet. So we use this open NDN network to exchange data between the users of the testbed, between the users of the workspace. So whenever a user connects, opens a workspace, they connect to the nearest testbed router, and other users will connect to their closest routers, and then they can talk to each other. The key difference that this model has from a traditional centralized server is that the NDN network, or the testbed in this case, does not understand or see the data at all. So the data can be encrypted as long as it is named in a way that the testbed can forward it to whoever wants the data. It is just infrastructure. The testbed is just like infrastructure, and it's not specific to the application either. Next slide, please. So the next one, once we have the testbed, we have NDN network, we can actually exchange the data. But in NDN, to fetch a data, you first need to know what the data is. And as it is, you need to tell everyone as it is produced. So in this example, if Alice produces a new piece of data, Alice needs to tell everyone that this is the new piece of data. So this is kind of different from a traditional IP where Alice will just push the data to everyone else. But we can do that in a distributed application because not everyone might want the data. For example, in this case, Bob wants the data, Kathy does not. And then there's also the case that there is a fourth participant who does not hear Alice's message. And so we have this, for example, they might be offline, and then we need loss recovery. Next slide, please. And to achieve this, we use synchronization. Sync is NDN's transport layer. It's short for distributed dataset synchronization. And essentially, sync synchronizes the set of produced data names among all the participants in a group using NDN infrastructure. So that way it is decentralized, does not require a central server to let everyone know what the state of the group is. And the state is essentially just how many different pieces of data are produced by each producer, part of the group, which we call the sync group, and what are the names of this data. So as soon as we synchronize this information, then anyone, if Bob's want a piece of data from Alice, they can just use the name as the network for the name that the data has, and the network will get the data for you. And in particular, for workspace implementation, we use the state vector sync protocol And these slides have links to the specification as well as the implementation for the SVS protocol. Next slide, please. And the way we use it is we use NDN sync to synchronize CRDT updates. So each update that we make to the document, any change that we make to the document is encoded as a CRDT delta, and then we take this delta and then we put it, make it into an NDN packet, secure the packet, and use NDN sync to synchronize this data to all the participants that are inside this group that are actually editing this particular document. And so to subscribe to these changes, you would do the process of joining the sync group, which is essentially telling the network that you are interested in this data, and then sync would actually bring that data to you, and it would do that reliably. Also considering the case that if you go offline, then you'll be getting these changes after you come back online. But that's actually relating to my next point, which is that all the users may not be online simultaneously. So if you just consider pure infrastructure, just a network, and then there are users connected to this with this decentralized distributed application, then if all of the users go offline after making some changes to the document, and someone else comes, some other user who does not see these changes comes online, then they can't actually get these changes from anyone because nobody's online. And to solve this, we need to have asynchronous communication. We need generic in-network storage, which will store these updates for when someone else comes online. Next slide, please. And so we call this in-network data storage as a repo. And once again, this is also infrastructure. It does not see your data, it does not understand your data. It just stores the data. And repo runs as part of the NDN testbed. So anyone who uses the testbed can use repo as well. And Workspace would store the data in the repo whenever as the data is generated. And if someone else comes online, they can just fetch the data from the repo. And once again, the repo is not application specific. It does not interfere with security. So you don't TLS to the repo or anything like that. The data is secured independently. And as long as the data is available in the network, that's the only function that the repo is providing. You can just fetch the data and independently use it in the application. Next slide. Back to Tianyan.
Yeah. So if we want to make some summary of our current effort, I think the biggest thing, number one thing, is that we take the semantic user identifiers from today's internet. I think that's the biggest difference between our effort and some previous efforts, say some collaborative dashboard or collaborative text editing app. That is, we really take the identifier from today's internet and try to apply that to build user-centric, data-centric security. Once user obtain their identifier and others can verify their identifier ownership, we can use that identifier to secure data directly by signing and do end-to-end encryption. And if the data are named, data are semantically named, and the keys are semantically named as well, then we only need a network that can exchange those secure data. It does not matter if this communication media is local, say IP multicast network or Indian testbed network or any sort of network, mesh of WebRTC. All those things can be used to exchange secure data. And I would say this high-level design idea of having the data-centric security with user identifier can be applied to other applications as well. I would say a concrete example is what we just experienced in the last few weeks. Next slide, please. That is, we have an undergrad from Shanghai. He came across our application, and he felt our application is interesting. So, and apparently he has little knowledge of NDN security decentralization effort, but he spent a few weeks of learning the CRDT libraries, how to program those apps. So he eventually developed a chat extension on the workspace very easily. He just used 1 week to start coding, issue the pull requests, and we get code merged. The only thing he needs to do is a little bit of YJS, CRDT library knowledge, and a bit of front end work, because he has to put the chat in the box, right? And what the role we played here is really about providing an API that can enable people to build the decentralized app with security built-in because he has limited knowledge of security. But what he did is basically using our API, using the CRDT API, so to make changes on some shared data structures, and our job is to have the backend to exchange the secured updates on the documents on the workspace. Next slide. So I think the fundamental, and from this effort, I think when we try to build some decentralized and secure application, I think there's 3 pieces we need to take care of. I think number 1 is security, and especially inside of security, number 1 issue is how users get their identifiers. Identifiers must be unique, semantic, and verifiable. Those are 3, I would say, fundamental requirements. If you want to build application, you have to address them. And after you have the user identifier, you can do data security. But how you exchange those secure data? You need, like, say, a rendezvous point to synchronize data among all the users. And then you also need to look at the questions to say, if not all the users, if you need to have some storage space, either a storage peers in the system, or like Varun said, relying on some in-network storage, since the data are secured directly, it doesn't matter where it gets stored. I think the 3S, the security, sync, and storage, are the basic pieces we identified through our development experience. And we also list our application URL here, and then people feel free to explore and try it. Yeah, thanks.
Okay, thank you guys. So I saw some comments in the chat. Are there any questions coming out of that?
I see a question say, can you DOS a repo by invalid updates, so it has to store and if we can DOS, I think it's basically talking about the DDoS defense. I think talking about DDoS, I think that is a separate problem, because if we're running a network, you have to have DDoS solution. I think in general has DDoS defense, and this work is basic. And this work, talking about long term, this work would rely on those DDoS defense mechanism. This work is about how you build decentralized app.
I would just add a bit more to Tianyuan's answer. I think DDoS is a network problem, and NDN has this unique feature that facilitate DDoS mitigation. Just for your information, we had a paper accepted by IEEE Communications Journal last week. It's a very detailed explanation on why today's DDoS over internet is so difficult to mitigate, and what is the unique advantage that NDN provides for effective mitigation. Whoever interested, I can send a pointer to the paper to the DINRG mailing list for your information.
We have a follow-up by Dave. Dave Moran.
Yeah, I actually wasn't talking about a network DDoS attack. I was talking about a computational attack against the individual nodes, since signature verification is an expensive operation. So if you can cause a reasonable number of messages with invalid signatures to arrive at a node, you can suck all its compute power. I mean, one of the reasons some of these security protocols we have actually force you to do a multi-way exchange is so that a server can't be forced just by receiving a message to verify a quite likely invalid signature.
Again, I think that's a very good question. The unique feature here is that the NDN network effectively mitigate the DDoS. So if I'm a node, NDN nodes that get attacked, I can just signal my nearby routers to push back the overloading traffic. Something that we don't think we can do with today's stateless IP network. But
I don't
that's
know how you
really
tell the good packets. I don't know how you tell the good packets from the bad packets when you can't tell which is which without trying to verify signatures.
I think this is really beyond the specific work presented by Tianyuan and others regarding to how easily one can leverage the libraries that these people developed already to build their own decentralized app. The DDoS issue is a more general question regarding the NDN network, and we can take that to the mailing list discussion.
Okay, that's fine. I just wanted to point out that there are subtle problems with the underlying protocols if they don't protect themselves, irrespective of what the network is doing, from the arrival of traffic that causes them to spend a lot of computational cycles doing useless stuff, which we learned with web servers years and years ago, right?
Wes.
Wes Herdiger, ISI. Looks like fascinating work. You hit my problem space of needing to work on a plane all the time. And so I greatly appreciate it. So my question, and I don't want this to sound like it's trivial, but I'm curious at the let me give you a system as a backdrop for implementing what you did, right? Git, for example, is a very distributed change control mechanism. And in fact, Overleaf does microtransactions to Git, or did at one point, in the same sort of way, right? So you're doing miscellaneous little tiny signed transactions that then can be synchronized with Git pull and Git receive. So to some extent, this is very similar, except that there's also a notification that goes through, NDN saying I have new change controls, right? I'm curious if the compare and contrast with such a system, what other benefits does yours provide? And again, I'm not trying to trivialize yours at all, because yours is actually usable and what I just described isn't. But
I think, as the last slide tells, I think there are three pieces. Synchronization and communication is only one part of building decentralized app. I still think the biggest difference or biggest problem is how you get the security down. And I think that is if we compare to Overleaf or compare to others, say, so-called collaborative apps, I think many of them do not have, maybe this is a bold statement, but many of them do not have a systematic security solutions. And that's the point we want to hit on.
And Wes, I want to give you a specific example. Your laptop is there, mine is here. Can these two boxes directly communicate in a secure way today?
So yes, so because I do this all the time with my own machines. I never go through GitHub or something else, right? I'm directly pulling and from individual things, which is what the advantage, one of the advantages of this is the notification of new information, right? That doesn't exist.
That's after. The very first thing is how you can communicate securely.
Well, so Git and underlying transport layer protocols handle that too.
Well,
but
current underlying transport protocols depend on connection.
Yes.
As we know, connection is a special case in communication. The more general ones are multi-point delivery and asynchronous communication. And those outlaws the so-called connection concept, either by TCP or by QUIC.
Yeah, so as I said, that's the NDN is independent, as you mentioned a bit ago. So I'll take it offline. But don't get me wrong, I actually think this is a great system. I'm not trying to disparage it at all. I'm trying to compare it against other existing building blocks.
But I think that's actually the first point of this work, that how you can provide secure communication as a data-centric, it's without connection. Today's internet security, honestly, is on top of connection, point-to-point connection. How can you do secure communications without that point-to-point
So
connection.
all blobs and Git can be signed. So there actually is security built into the Git blobs, but you still have to transport that over a connection-oriented protocol. That I give you.
Okay, question for me. So the reason why such systems today are typically implemented in a centralized fashion is, as far as I can see, the security bootstrapping that we just discussed, then consistency management for like parallel edits, and also scalability concerns. So CRDT, I mean, it's not a silver bullet that solves all your consistency issues. It's more like a concept that you have to apply to certain application-specific data types. I was wondering, so in the examples you showed, look like you are communicating updates at certain, let's say, buffer positions in the document. How would that work if you have overlapping updates? How do you resolve those conflicts in your system?
Okay. I think, for example, if I don't know if you are mentioning a case to say two persons they are making changes offline, then suddenly they come online and exchange data. Are you asking whether we can resolve the so-called conflict in that context?
Yeah, typically CRDT applications have some kind of conflict resolution strategy. Just wondering how you do it.
Oh yeah. For example, for the specific case I just mentioned, if two people are adding some lines simultaneously offline, we will accept both changes. And we think CRDT is merely a tool to handle potential conflicts in the communication end. But two people making changes offline simultaneously, I think that belongs to the application end. That is, the application users, the real application users, the human users need to resolve this conflict. And also, that's the generic problem. Even if you use Google Doc, right? Google Doc sometimes still have the same problem. That is, if two persons are editing somehow not in the synchronized way, you would see the two sentences appear in the same position. I think this is really up to the application decision. It is really the logical correctness of the content has to be ensured from the application end, not from the workspace end, which would simply serve as a shim layer to securely exchange data packets.
Okay, thank you. All right, I see no other questions. Then let's move on. So with our discussion of RFC 9518. And how are we going to do this?
I have the slides up a little bit. So let me just get the conversation going while Dirk is uploading the slides with the questions. Oh, that's here already. I think it's like a year ago, or even more than that, there was a very active discussion regarding this centralization, decentralization. And this group organized a very successful workshop and we produced a report after some delay. However, lately, the conversation on the group mailing list seemed to die down, which I attribute to people being busy with all these other demands. I think that the publication of this RFC 19518 by Mark could be a good triggering points to energize us starting a new round of conversation to get things going, moving this effort forward. Because if we get distracted to other things, we somehow delay the progress on this very important topic. So this last bullet on today's agenda is meant to get the conversation start or restart, depending on how you view that. So I think the publication of this RFC laid out a number of issues. But it's not like the last word on the topic. I think that it's really the beginning point on the conversation. To get the discussion going, I just on top of my head made a short list of questions. By no means those questions are the good ones, or not missing any good ones. And the ordering is also a little arbitrary. Like I said, the goal is to ignite the conversation and not to say we only care about those few questions that I put out. Having said that, you can move on to the next one. So you can see that the very first question is really about the definition of distributed versus decentralized. This question was brought up at the NDN community meeting, which is 2 weeks ago before this IETF. So then I'm just trying to put it out to say what people's view on the answer to this question. If we go through the rest of the page, since it's shown up here anyway, this relates to the things, once we figured out what's the difference between distributed and decentralized, there's also a bunch of things we considered consolidated or otherwise centralized over the last decades or so. Now, given the multiple things get centralized, which one we actually think we should tackle on first? And what are the driving forces before for all this movement or the changes over the internet over the not too long time period? So I would just invite people to throw out your opinions, conversations, or otherwise the criticisms on those questions to have dialogue going. Now I see there's already a queue.
It's hard to be a note taker and a contributor at the same time. For me, hands down, the obvious one is user data, because that's, I think, where the world has really lost, like the rest of those most people don't care about, except that some of them are related, right? Popular applications like search, maps, and videos, they all contain a lot of user data because of what the distributors are actually doing. But where I think, the society at large has really lost some important segments in terms of protecting user data and self-anonymity with the advent of more and more webcams and everything else, right? We're losing the ability to have a notion of a protected identity. So if I could pick one that I want solved today, it's that.
Thank you, Wes. Next one.
Hi, Andrew Camping. I guess the one that I don't think is on there, unless it's somehow implied, protocols, which I think is quite pertinent to the IETF in the sense of protocols that drive centralization as an inherent characteristic of their design. And dare I say it, some of those authored here absolutely accelerate centralization. But I also agree with Wes, user data is fundamental.
We have Stefan.
Could you give an example of these protocols, for instance? I really don't see what in SMTP is responsible for the centralization of email in Gmail, Outlook.com, etc. So I have serious reservations about the idea that protocols can have properties that push to centralization.
So Tobias Hibich, Max Planck Institute for Informatics, and I would like to pick up that point of what in email pushes centralization and what in the email protocols pushes centralization. And the first and foremost thing is complexity. And this complexity is being enforced by the centralization of email platforms. So Google can make certain claims as to how an email has to look when it's being submitted. We do have two different transport security enhancement protocols. We have DANE and MTA-STS. MTA-STS has mostly been pushed by people who say like, well, DNSSEC maybe not, while DANE classically is pushed by people who say like, DNSSEC, we like that. So when you now have large centralization, maybe one of the operators might fall into one or the other camp, and then they might say like, well, if we want to send email to you, you have to do MTA-STS. All of a sudden, people have to figure out how to do MTA-STS. So this growing complexity and growing complexity of operating a standards compliant mail setup in conjunction with large operators having the ability to say like, okay, then we just now take your mail. That is what is pushing centralization, because in the end, users want emails just to arrive and being read and, well, receive emails. So if that is being harmed by that centralization, people will be like, okay, struggle with my own mail server or get Gmail. Well, then I get Gmail.
Okay, so this is just my personal opinion. So RFC 9518 talked in a, I think, far more nuanced way about the centralization and decentralization problem, and also try to avoid a black and white picture. It's a kind of say, okay, there are say good reasons to centralize say certain infrastructure elements. Simplicity is one reason. So I'm not quite sure. So asking a question, so what to decentralize next is necessarily so useful. I think we need to understand the, say, socioeconomic, say, realities, and then the threats that stem from that. So things that Wes mentioned in the beginning. So just asking what to decentralize next is maybe not the best question to ask, my view.
So we deregulated. We opened this up to what we'd call market forces. The underlying drivers here are not RFCs or standards. The underlying drivers is investment. Now, in one of the more telling documents, I think, that ever appeared was a Wall Street Journal article by Peter Thiel, one of the guys behind PayPal, and he said, competition's for losers. And what he really meant is, what you can't dominate, you commoditize. If I'm going to fund someone with venture capital, I'm not going to fund someone to make a competitive product with other products. That's for losers. I'm going to fund projects that completely dominate their environment. What we have seen over the last 15 years in the application space is an economic impetus to create application level environments that completely enclose the user. And that's what gets money, that's what gets investment backing, that's what we end up working at as worker bees inside these companies. Meta, Facebook, did not intend to make a competitive application. They intended to make a complete and comprehensive environment that basically resisted any form of competitive entry. Kindle the same, etc., etc. And so when you go, well, how should we decentralize? The answer is, last I heard, you weren't a venture capitalist. Last I heard, you weren't funding development in this industry. Good luck, but if you're not doing that, you have very little impact. That because we deregulated, because we started to open this up into the tyranny of economics, you start opening this up into an issue where size matters, volumes matter, capturing users matters. And everything you're decrying about centralization is a logical outcome of the investment model that Silicon Valley took up, because there was no other model around and the money had an agenda. And so in many ways, I find Mark's observations in this RFC, I can sympathize with what he's trying to say, but the amateur economist in my head says it's anti-gravity. He wasn't on the other side of the fence pushing private money into this system, wanting not just a slight return, wanting to fund another unicorn, wanting 10x, 100x on his initial investment. Every single time that these things have been successful, it has been not only with breathtaking scale, but with complete dominance of where they wanted to push. Complete. And then we all go, well, that's pretty central. And the answer is yes, that was the intention. They succeeded. And in saying, well, should we push against that? The answer is, well, who are you? And what kind of market impetus do you have behind you to create a different structure? This industry, and certainly up at this level, is not naturally a competitive industry with lots and lots of folk. It's an industry that wants complete control over all of its supply channels. Google doesn't build submarine cables because they've got nothing else to do on a Wednesday. They hate being reliant on anybody, including the submarine cable industry. They build it to exercise control. This dominates this industry. Why? Because we're rebuilding it from the bottom up, and we're rebuilding it with private money. We're rebuilding it to actually give the venture capitalists their 10x return. And the way that's done is with massive scale and massive centrality. And going, well, it's really good that everyone runs my decentralized application. Yeah, great. It ain't going to happen in this world in this way. The major forces out there in the consumer market, Facebook and so on, are forces that capture users and enclose it in that application space. And that's all they do. And so I suppose, have fundamental issues even with the research group to think, I don't think this group really understands the economic realities that are out there. And if you don't understand that, you're saying things that you might, emotionally like, and it certainly harks back to the internet of 1989 or something, but it doesn't map with the tensions that have built an application space that dominates financially everything else. There is no layer 3 because it's economically unimportant. It's completely unimportant. All the money is in apps, and those apps capture and dominate. And that sort of builds all the rest of this ecosystem. So the driving forces behind all of those movements, venture capital.
I just injected myself into the queue. So Jeff, thank you so much for your insight. You say that maybe a bunch of people who do not understand the economical factor beneath all of this, thanks to people like you who actually bring that knowledge to this group. But having said that, the world is not that pessimistic. Once we understand the problem, let's figure out a way to overcome them. Again, just thank you for the comments.
Okay, we have Raul in the queue.
Do you hear me?
Not really well. To speak a bit louder.
Yeah, I'll try and come closer to. Does this help more?
A little bit, but not really good.
Okay, I'll try and speak as loud as I can.
Yeah, it's better.
Yeah. So, I mean, there is a lot of truth to what Jeff has just said. And if you take up Yanis Varoufakis' thesis, he just expounds on this fact that it is almost to the point that the internet has introduced a new form of feudalism. Having said that, ultimately, what we are calling users are people want services, and
I think we lost you. Or maybe let's come back to Raul.
Hello. I lost you for a moment, I think.
Yeah.
Yeah. Okay. So, say one person wants to buy and one person wants to sell in another city. There's no way for them to establish a connection. A platform comes in. You want a taxi. You have no way to connect to a taxi driver. A platform comes in. So, any place where there is no way to establish a connection or a consensus is where the opportunity for centralization arises. So if we can figure out the places where we need to do this and come up with consensus beforehand as a society, as governments, then we have the opportunity to get ahead of this. But that means we have to recognize, just not leave it to capital, and as a society, through governments, through standards bodies, through other mechanisms, figure out ways of coming together. Yeah, I guess that's it from me for now.
Okay. Thank you.
Hi. So I'm Vittorio Bertola from Open Exchange. And first, as a messaging person, I would much like to see messaging somewhere on the list, because I think it's another very basic service, both email and instant messaging, that through which, I mean, platforms exert control, centralize, and gather a huge amount of data. And I mean, a couple of people already mentioned how we got this. But I think the IETF has a responsibility in decentralization of email. And it's also an example because it happens in other sectors, because simply by increasing the complexity of the protocols and adding more and more and more things on top of the original services, it made self-hosting email in general. I mean, it makes it very difficult for services to be hosted by anyone who is not a very big company. And there are more protocols in the making that either rely on like a centralized trust list like ARC, IRC, or I mean, even protocols like OHI have basically a component that makes it unlikely that they will ever be deployed at scale by anyone but 3, 4, 5 very big. So this is because I want to get to the question of how can we stop this, and I don't want to be disrespectful or offensive to the people. I mean, there are many people in this community that sincerely want to do something here, but I think that the technical community basically has been promoting centralization. And most of the people that participate here work for the companies that benefit from centralization and are pushing more centralization. So it's really hard to imagine that the IETF can do a lot in this field, especially given that in many cases, it's not that there are not the protocols, but it's the deployment of the protocols that is made in a way that centralizes everything. So to me, I mean, in the last few years, I've come to the conclusion that the only hope I have is governmental intervention, which is what we've been trying to get in Europe, and we'll see whether it works. At least this is the first time we get, for example, Meta to open up WhatsApp and Apple to accept other app stores on iOS. So, I mean, there are things that are happening, and they are only happening because the European Union has started to make regulation. Otherwise, they would not have happened. But of course, they will not be successful alone, because then these create opportunities. But I agree with Geoff. If there's no industry ready to invest in these and create alternatives, we'll not get anything. But I'm really negative on the idea that we can solve centralization at the IETF at the technical level.
Okay, thank you. Miriam.
Thank you. We need something for the vertically challenge for this. My name is Mariam Lee. I'm from the IO Foundation. We are registered in Estonia, but we are based in Malaysia. So we are a non-profit working on our advocacy called Data-Centric Digital Rights. And within DCDR, we have 3 components: data accuracy, data authenticity, and data agency. And one of the biggest problems we have is the non-existent taxonomy or reference that we could sort of go to in order to define what does it mean to be, to be data-centric, digital rights compliant? What does it mean by digital harms? What does it mean by, not protecting your data or not protecting your human rights in software, really? So just a comment to address the question, what is or are the driving force behind a movement, something like this? And thank you for consideration. Thank you.
Okay, thank you. Alexander?
Yeah, I would like to comment on the previous comment about complexity.
Can you say your name first?
Alexander from Siemens. Thank you. So a previous speaker mentioned that a reason could be complexity, but I disagree. And as an example, there are fairly easy ways to spin up a full stack of an email thing by just writing Docker Compose up and editing a few configuration files. The problem is that your messages will be rejected because some institution doesn't trust your IP address or thinks it's not trustworthy. So I think the reason it doesn't work well is because some players in the market are just bullying the smaller ones because they can do so easily. So the solution is not a technical one, but you just need something with a bigger stick to put them in their place. And an example I could provide is maybe what happens in the EU with the GDPR and how it can influence the company's decisions, and how also in the EU, Apple is being pushed towards opening their own walled garden a bit. So I think regulatory pressure on the bullies is one of the ways to solve it. And another thought is to make systems more transparent. So I agree that users want services, they want nice features, they want it to work, but they're not aware of the full costs they're paying when they choose one particular solution. Costs in terms of privacy erosion, as a minimal example. And again, the GDPR, which requires transparency, what data are collected, for what purpose, who else gets it. If this is indeed enforced, people will probably choose solutions that are more open and less abusive, and this could lead to a better future. That's it.
Okay, thank you. Arnaud?
I'm at the right size, yes. So Arnaud Tadei, Broadcom. So I have a few points to make regarding serial intervention. So the first one on the complexity, I disagree with the previous one, right? Because I had the chance back to email to create the third largest email platform, internet mail platform back in '93. I was at CERN at that time. At that time, what we had is 8 NFS-based systems, DEC mail systems, IBM mail systems, and so on. That was completely distributed, completely heterogeneous. The only way we could centralize was because we had suddenly a protocol that allowed us to do that. The difficulty we got was how to implement that protocol. Because to store the emails, we realized the combinations of SMTP, IMAP, POP, etc., let alone plenty of other things like notifications and so on, led us to realize there were 3 possibilities to implement the store. Either you were doing file system based, you were doing it database based, or hybrid. And for some time, the database people led to what we know as Exchange, Lotus Notes. The file system based lost for a long time, that was NFS based. And in the middle, you had another type of solutions like Sun Microsystems and others that was hybrid. The big winner became Gmail because they realized they could change completely the model by changing the file system. Gmail is based on Google file system. And that's a very unique and very clever way to do that. The issue you have is the lock on when the email arrives in the inbox. The pressure on the lock is phenomenal in the system. And that's a complexity you need to resolve to pass. And this is forcing you to concentrate your efforts to organize something that will scale, because once you set up your service, then you're going to spend your time to manage disk space and archives and backup and all of that. And that costs a fortune. So you need to organize this in a way that is economically effective. So the question here is more about whether a protocol can give the conditions for when, to the good points of Geoff when he explains the economics, suddenly 2 worlds start to meet. So it might not be just one world is putting the pressure from one side or the other, it's perhaps the combination of 2 forces at the same time that suddenly meet, and now they can give each other the synergies that make them evolve in that direction. That's one set of comments I want to make. The second point is to just very good point. I have a slight difference on the VC problem, right? Because the VC, they can be a curse and a benediction. So I work in Broadcom. So Broadcom, no secret, it's about domination. We buy products that are dominating their market. So I completely understand the point you make, completely agree with that. However, I am in the security industry. in the second industry, that's the industry of the losers. I completely agree with you. If you look at how many we are, and I was Symantec. Symantec was acquired by Broadcom. Carbon Black was acquired by VMware. Broadcom acquires Symantec, now acquires VMware. Others were acquired. The big question when I have some group CISO that ask me about why we behave certain ways, my answer is very simple. How many of the 500 players in security make money? How many? And how many are backed up by VCs? Because they hope the hockey stick effect. And most of them will fail. Right? So we have an issue here because the VCs play some very strange strategy. There is a fantastic explanation at Mobile World Congress by my president about what is the strategy of my company. I would recommend you look at that because that's going to be insightful for this discussion. The third point I would like to make is a remark that we already had this discussion two meetings ago in this room. There is one aspect you miss. I mean, when I had the chance to work with Bill Yeager, when I was at CERN, Brian Carpenter was my boss. I had Tim Berners-Lee in the office in front of mine. So I've seen certain moments of the history here. Bill, I met Bill in July. And Bill Yeager was, let's say, somebody who contributed to IMAP servers and so on. And he told me we made a big mistake. We allowed centralization to happen. We are like, I take my bicycle, I leave my home from my little path, I arrive to a big highway, and I try to rush across trucks and so on to get my data, then turn 180 degrees, come back, and I managed to reach home. That's basically what you do every day. So he realized the implication I'm telling you 30 years ago. So the problem we have behind the scene is something that is not on this slide. So agreed, I would like to see instant messaging, all of this in this slide. But one thing we don't consider is the point of design. The method of design, we completely forget it here in the IETF. We don't understand the nature of design. We don't understand the steps of design. We don't understand that there are a number of things from anthropology, ethics, legal, technology that we completely miss and have not codified. This is where we could find some answers on where are we introducing centralization, because sometimes it's unconscious. Anyway,
okay, thanks. These are great points. I just wanted to point out that we have 3 minutes left. So if you could be brief in your statements.
So Tobias Sievich, MPI Informatics again. There's a lot in several statements here to unpack, and I would like to actually pick up with the other speaker about the complexity of email. But one core thing is lack of capabilities and loss of capabilities with centralization. Yes, it's nice that we have a Docker container set up which we can bring up, but we are lost when something in there fails. It's nice that we are dealing with all of this centralization, but we are losing the ability to keep building these systems. And with that, I'll keep it so the others can talk too.
Okay, thank you.
Hi, Nicola Rustignoli, Science Association. 2 points. First, I second many of the previous speakers in saying that the centralization is probably not necessarily related to protocol design, but also to other forces like market and economics. And so lots of the people before me, they mentioned regulatory intervention. And I think in the EU now we have a few examples where this happened already. For example, the Digital Market Acts that kind of open up the App Store. And this opens up to a separate question. With these regulations, for example, in Europe now you have a, let's say, different App Store experience, whether in Europe or you are somewhere else. Or with GDPR, sometimes you have some websites that are not from Europe that they block users from Europe because they don't want to have to even deal with GDPR. And so the question that I don't see on the slide is how does this centralization or decentralization then affect fragmentation of platforms and so on? when the regulators come into force, because then every country will have their own regulations, and then this will, I think, open up additional questions. Thank you.
Thanks. That's a good point, because sometimes the companies that you think should be regulated are national champions in another country. So we quite have that situation at the moment. Thank you.
Hi, Andrew Campling. 3 very quick points. First is in terms of protocols, which I believe are driving centralization. One was mentioned already. If you look at Oblivious, any of the protocols which let the app determine the routing of the traffic, that's putting more power into the app's developers and taking it away from stopping network management and so on. So I think that's a force for centralization as one of many examples. I think you could make a reasonable argument that the push on anti-fragmentation of the internet is arguably, you could reframe that as a disguised way of advocating for centralization. Just put that out there, as you might want to look at who's backing that overall program. And then the third point, I think it was Nick Merrill from UC Berkeley, is doing a study on the use of SDOs as control points. So in other words, standards bodies are themselves aiding centralization by virtue of the convening power of the big companies. Yeah, they just can outmaneuver and push through developments in the SDOs that frankly none of the other organizations can possibly compete with.
Okay, thanks. Wes, you have, okay. All right, great. Thank you very much. Very engaging discussion. I'm sorry that we have to close the meeting now, but I really like to ask you to continue this discussion on the mail list. So many people shared really good ideas, also pointers to other resources. We really need this on the mailing list, and we know that this is like a challenging setting, and the task for this group is to figure out, so what are meaningful, say, work items or topics to focus on for the future. And so we don't want to dictate this. So it's really, really good if we could have some discussion on the main list or some suggestions that you would like to share.
If I may, for the newbies like me here, we need guidance. How can we help? What do you expect us to do? And what should we produce? Which are the delineation you want from us? And so we need a bit of
okay,
not just us proposing things, but please give us a way forward.
All right. Okay. That maybe we're also happy to talk offline with people, of course.
Move the conversation to the mailing list. As a matter of fact, this is only the first page of questions. There are more questions. We haven't had time to get into yet, but I'll move on this onto the mailing list. Thank you, everyone.
And thanks very much to Wes. It was a hard job today. Yeah, no, it's there's areas right now. Thanks much.